We are following Helene's path as the storm pushes inland, causing catastrophic flooding in the southeast. The storm is one of the biggest on record to hit the Gulf Coast, and that is no surprise to our next guest. Climate scientist Michael Mann says climate change is causing stronger and more destructive storms. Michael is also the director of the Penn Center for Science, Sustainability, and the Media at the University of Pennsylvania and the author of the book, Our Fragile Moment: How Lessons from Earth's Past Can Help Us Survive the Climate Crisis. All right, Michael, thanks for being with us, and just tell us why this hurricane, Helene, was so bad.
Yeah, thanks. It's good to be with you, Brianna. Unfortunately, we're seeing yet another devastating storm make landfall, a 10-foot storm surge, millions of people without power, a couple dozen people have lost their life. And so what we're seeing are these more destructive and deadly storms that are intensifying faster. And this is another example of what we call rapid intensification, where in the space of about 24 hours, it went from a tropical storm to a major hurricane. In less than another 24 hours, it became a Cat 4 hurricane. The science here is pretty rock solid. It's not, it's not rocket science. It's pretty basic physics that tells us that the warmer you make the oceans, the more moisture they evaporate into the atmosphere, the more energy there is to intensify these storms, the more rapidly they intensify. When they're more intense, when those winds are stronger, you get a larger storm surge. They pile up more water. And when it makes its way towards the coastline, you get the sort of catastrophic flooding that we're seeing, as well as inland flooding, because, again, the air is very warm. There's more moisture in that storm. And so as it continues after it makes landfall and it progresses, sort of northward in this case, it continues to dump out huge amounts of rainfall. And they're seeing, quite a bit of flooding even inland in the southeastern U.S.
Yeah, we're looking at those pictures. It is unbelievable in Atlanta, where we see this scene from earlier today. When we look at how Helene compares to other recent storms, I do just want to give people some perspective here. It was 420 miles wide. Idalia last year was 219 miles wide. Ida in 2021, 247 miles wide. Michael in 2018, 272 miles wide. So we see what a big difference this is. What do you see looking at those numbers?
Yeah, and so this is another trend that we've seen, that these storms are larger. Just the radius of maximum sustained winds, how far out you can go and still from the center of the storm and see, still see hurricane strength winds. Though we're seeing storms that are much larger in that sense. And the science here isn't quite as well developed. We clearly see a trend towards larger storms. Why exactly that's the case is still being sort of worked out and debated by scientists, but I can tell you what the implications are. When the winds are strong and when those winds extend far out from the center of the storm, it's going to pile up more water. The larger the storm, all else being equal, the more water it's going to pile up. The stronger the winds, the more water it's going to pile up. So you put those factors together, very intense storm, very large radius of maximum sustained winds, of hurricane strength winds, and you get these huge storm surges like what we saw here with Helene, 10, 11, 12 feet, as I understand it, along parts of the Florida's Big Bend coast.
So how do we turn this trend around?
Well, turning it around is going to be tough, because the reason we're seeing these more intense, more extreme storms is because of how much we've warmed up the planet, how much we've warmed up the oceans. And that warmth is sort of baked in for the near future. We're not going to cool the planet down in the absence of substantial new technology to suck carbon out of the atmosphere. We're not going to be able to do that for the foreseeable future. And so we're sort of stuck where we are. We can prevent it from getting worse. And one of the things that climate science has taught us over the last dozen years or so is that we're now much more confident that when we bring our carbon emissions from fossil fuel burning down to zero, when we stop polluting the atmosphere with carbon pollution, the planet will stop warming up. And so there's a direct and immediate consequence of our efforts to decarbonize our economy. And so that's what we've got to do. We've got to transition as rapidly as possible away from fossil fuels towards renewable energy. And we've got an upcoming election here where we have a stark choice before us. We have a candidate on the one side who denies that climate change is real, calls it a hoax. We've got a candidate on the other side who recognizes that this is one of the great threats we face, and will try to build on the progress that we've already made in trying to do something about the problem.
All right, Michael Mann, we appreciate you. This is just incredible what we're looking at here, and you really put it into perspective. Thank you.
Thanks very much, Brianna.
Next.